Hello and welcome to another one of D's ADD videos. Today we're going to be looking at equilibrium constants in terms of pressure and trying to convert that to equilibrium constant in terms of concentration. So we've already established in the concept video that we could write the equilibrium constant either in terms of concentration as a ratio of their products to reactants, with the coefficients being their exponents, or even as a ratio of partial pressures with the same relationship of coefficients and exponents. And we established that there's a relationship between the equilibrium constants that involves the change in moles of gas using the coefficients of the chemical equation, the gas constant, and the temperature in Kelvin. So if we were to look at this problem and say that at 500 degrees Celsius ammonia is formed with that equilibrium constant in terms of concentration, and I wanted it in terms of pressure, how would I go about doing that? The first step would be to calculate the change in moles. So we know that there's 3 moles here. There's an understood 1 there. So that's 4 moles for the reactants, and then 2 moles over here for the products. So if you did products minus reactants, it would be 2 minus 4, which is a negative 2. And then if you were to plug into the equation, okay, and we would get and that would be raised to the negative 2. And if we multiply all that out, oh, I'm sorry, 298 was the last example I did. This should have been 500 plus 273, which is going to be 773 Kelvin. Not 298, that's a mistake, I apologize. This is what happens when you record videos at 2 a.m. So I'll put that in a different color just so you are aware that I did make a change, just in case you left the room or something. And when you multiply all that out, you should get Kp is equal to 1.5 times 10 to the negative 5. Alright? So that's basically it for the transition from one to the other. Make sure that you look at the coefficients, get the change in moles, plug in the constants, and solve for whichever one they want you to solve for. I hope that's clarified things. Practice, practice, practice. Thank you and have a nice day.